All right, today we're going to learn about indeterminate powers. Now, this is another L'Hopital's rule, and there are three main indeterminate powers we want to talk about. One is if you have 1 to the infinity power, that is indeterminate. In other words, you're going to have the base going to 1 while the exponent is going to infinity, and we don't really know what that is because it depends on how it approaches 1 and how it approaches infinity. Another indeterminate power that we have is 0 to the infinity power. Again, is the base going to 0? How quickly is that going to 0? How does that go to 0? How quickly is the exponent going to infinity? How does it go to infinity? And another indeterminate form that we have is going to be 0 to the 0 power. Okay, so what is the key idea for us? Well, we are going to manipulate things just like always. We're going to manipulate um, so that we can use L'Hopital's rule. Okay, so indeterminate powers, they sort of have a general process. So let me describe that process to you. I think the first thing you would do is you would set the limit equal to y. In other words, you're going to introduce this variable y. The second thing you're going to do is you're going to take the natural log of both sides. The purpose of taking natural log of both sides is that this will allow us to use the third law of logarithms. Remember what the third law of logarithms was? That was the one where if you had log a to the r power, the third law of logarithms says that you could bring this power down in front. So this is actually equal to r times natural log of a. And by doing this, we would essentially turn our indeterminate power into an indeterminate product. And we already know how to handle that. Okay. The third thing you want to do is you want to take the limit. Maybe you need to use L'Hopital's rule. So we're going to use L'Hopital's rule. And then the last thing to do, and it's important that you don't forget this, so let's put a little star here. You want to raise both sides by E to recover Y, right? In other words, in step 2, we took natural log of both sides. So you're going to have a natural log of Y there. Now we got to raise both sides by E to get the Y back. So this will be easier to see if I do an example for you. So let's take a look at example 5 here. Okay. So the first thing that we do is we're going to write y is equal to the limit as x approaches 0 from the positive side, x to the x power. Okay. Then we're going to take natural log of both sides. So I got natural log of y is equal to the limit as x approaches 0 from the positive side. We get natural log of x to the x power. Now I can apply the third law of logarithms and bring this power down in front over here. So when I do that, I get natural log of y is equal to the limit as x goes to 0 from the positive side, x times natural log of x. Now, we've actually already done this example before, so I'm going to mention we did this example earlier. I believe it was in the first video on 6.8. So we know that that is actually equal to 0. So it equals 0. Okay. So then we end up with natural log of y is equal to 0. So I'm going to put little arrows on the left to indicate that we're going from one step to the next. So now we've calculated a limit, but we want to calculate our original limit. So at this step, we need to raise both sides by e, or take e of both sides. So this gives you e to the natural log of y is equal to e to the 0. As we know, e and natural log are inverses of each other, so e to the natural log of y is just y, which was the thing I was trying to find, and e to the 0 is 1. So our final answer is going to be 1. Okay, so that's it for indeterminate powers. I hope you enjoyed this video. Take care, everyone.